We're going to start talking about a type of equation called absolute value equations. Now, absolute value equations are simply a fancy way to say how far away are we from zero. So I've drawn a picture right here of the absolute value of 10. On a number line, I've indicated the point 10. Taking the absolute value of that just asks us, how far away is this from zero? So if we go from here to here and measure that distance, it happens to be 10. Not too tough on this one. Let's take a look at the absolute value of negative 8. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 is over here. When we figure out the distance of that from 0, going from there to there, we measure things with positive numbers. Distance is always measured in positive numbers. And so from here to here, there are 8 spaces. That means the absolute value of negative 8 is positive 8. Now we're going to see that with all of our absolute values. When it's positive, it's simply the number that we have right here. So the absolute value of 10 equals 10. When it's negative, that absolute value is going to measure the distance from 0, and it's going to become a positive number. So the absolute value of negative 8 is positive 8. Now, these two have some calculations that we have to do. When you are calculating with absolute values, it is the same in the order of operations as parentheses. It acts as if we have parentheses around here. So we have negative 0.9 times 10. That gives us negative 9. When we take the absolute value of negative 9, that gives us positive 9. Right here, we have to pay attention to our order of operations because we're multiplying. This negative 3 is right next to that, which means multiplication. But inside, we also have this addition. And so we've got to do inside this grouping symbol the absolute values first. 2 plus 5 is 7. So we have negative 3 times the absolute value of 7. Now we're going to figure out the absolute value of this, which is just 7. So we end up with negative 3 times the absolute value of 7, which is 7. And then that gives us negative 21. So we're done with that. Now that we have seen some absolute values, we're going to take a look at a few different equations and see what we can do to solve equations that involve absolute values. All right, our W right here is unknown. We want the absolute value of W to equal 6. That simply means that the distance of this number from 0 has to be 6. Well, let's draw a picture of that. Here's 0. 6 away from 0 is going to be over here. 1, 2, 3, 4, 5, 6. Over here at positive 6. 6 away from 0 also could be in this direction. 1, 2, 3, 4, 5, 6. That would put us at negative 6. So we have 2 locations right here where the distance of those numbers is equal to 6. So W could be equal to positive 6, or W could be equal to negative 6. Those are 2 options for our solutions right here. And we can see that when we plug them in, the absolute value of negative 6 is positive 6, and the absolute value of positive 6 will also be positive 6. Let's take a look at this one. The absolute value of x equals 13. So again, let's graph that. Here's 0. The distance from 0 has to be 13. Well, that could happen over here at positive 13, or that could happen over here at negative 13. So our x could be 2 different values. X could be equal to positive 13. The absolute value of positive 13 is 13. Our x could be equal to negative 13. The absolute value of negative 13 is also 13. Let's take a look at this last one. Now this asks us to find a number where the distance from 0 is negative 7. And as we talked earlier, distance is always measured in positive numbers. So for this one, there is no solution. That's one thing we have to be careful of with absolute values. Absolute values cannot end up being a negative number. So we have no solution. And our question asks us to graph the solutions. We've done that with both of these. We've graphed the 13 and negative 13, the 6 and the negative 6. When there is no solution, there is no graph. So we're just going to leave it blank. Thank you.